Hi, myself Dr. Devaruto Mohanty from Bhubaneswar, Odisha. I am a biology faculty having 5 years experience in this field. Today I am going to discuss on amplification of gene, means gene amplification. Amplification what exactly means? Enhancing the number, means to increase the number. Okay? As we all know, gene is exactly a part of a chromosome. Means first of all we have to enter why we are going to amplify. Why? Then we will know then what. What exactly that? Then how we will do. First of all, 3 question answer we will get here. Why we will do amplification? Second thing, what exactly we will do with the process and how we will do. Okay? First, amplification, why we are doing exactly amplification? Let's say during the process of our biotechnology, when we have got the gene sequence of a desired target species, the target species that exactly we are getting might be available for a short period of time. Okay? So for that species, we could able to amplify, means increase their number for a certain period of time. Okay, if we are not increasing their number, that means we may lose them. For example, I am here at Bhubaneswar. At present time, I get a gene sequence of 1000 kilobase pair of a X bacteria. Okay, that bacteria may be loose if I am not getting amplified the gene sequence. Okay, so for that purpose, during the process of biotechnology, to get a proper gene sequence and for a long term process, the amplification is most essential. Clear? Then second is the what. What is essential? The essential part is once amplification over, second step is the what exactly is the amplification. Okay? During the process of amplification, we are getting the more n number of gene sequence. Okay? That gene sequence can able to utilize for a target product. Let's say your insulin, let's say genetically modified crop, let's say your plant, species, whatever might be. Okay? Then things comes how the amplification process. That exactly means your PCR or polymerase chain reaction. Okay? If we are entering the history of the process, it's a process. Okay? That is for the first time was developed by Gary Mullis in the year 1969, which have been not there in your NCERT. But why they develop? Because they develop a gene sequence which are getting degraded. To store that gene sequence, they are getting amplified. Okay. So that next come to the process. Dear students, the amplification is not a big process, but it's a very simple like a DNA replication. Okay. The difference is that, see, this is my replication. This is my DNA replication. Okay? And this is my amplification. What are the similarities? Okay? Replication exactly, as you know, let's say this is my gene sequence. Okay? There will be addition of some enzymes. Let's say for your topoisomerase. Then your primer, then your helicase, then your addition of your primer. Okay? Then this primer help to separate these things, means the topoisomerase and helicase. Then addition of the primer. Okay? Then after that, addition of the polymerase. The similar process will be there in your amplification. But the difference is that this is in the inside the cell, this is in the in vitro condition. In the laboratory environment, we are going to prepare the n number of species of DNA. Okay? So very simple, means there is a machine who will prepare the n number of base pair. We will provide the database means we will provide the desired things, means the enzymes and primers. Okay, depending upon that, it will prepare a number of bases. This is the whole total of the process. Okay, let's enter into the process. How it is happening? Okay, see. First of all, you clear this. This is a process inside the laboratory, means motion is doing. Okay, we have to provide all the materials to the motion. Okay, so this is my test tube. Inside the test tube, I got the pure gene sequence, means DNA sequence. Okay, to that I have to add the primer, means desired primer. Normally for the amplification, we have to design a primer. We don't know what exactly the gene sequence. We have to design a primer. Okay, accordingly we have to add the polymerase. Okay, polymerase. Do you know polymerase? The role of polymerase is proofreading activity and flow from 3' to 5' DNA polymerase. But here exactly what happened, the entire thing will be there, but in a different way. First of all, the gene sequence, let's say these two are my gene sequence. Okay, first of all they have to separate, like your replication, they will be separate. How they are getting separate? Means this is my base 1 and this is my base 2. They are getting separate. How they are separate? By providing a 90 degrees Celsius of temperature inside the laboratory, it is getting both the base pair are getting separated. Clear? Which is there inside our cell by the help of the Poisson-Morse. Clear? Then similarly, we are applying some primers. Primers here. Let's say these are my primers. Okay? The primer they will be entering is the first step. This is your denaturation. Okay? Then second is your aniline. Okay? And third one is your renaturation. Okay? In aniline exactly what happened? Normally 42 to 62 degrees Celsius. According to NCERT. Normally in my practical exposure it has been standardized, that is 57 is standard. Okay? Means addition the primer, exact sequence of primer there. Then to that the gene sequence, the targeted gene sequence will be attached, and to that primer we will be adding a polymerase. Okay, polymerase is exactly here you see, as we are applying a high temperature, means 90 degrees Celsius. Definitely, if a normal polymerase will be there, means DNA polymerase will be there, it will be not functional. Means high temperature may interact with the DNA and they will disrupt the base pair. So in that, for that purpose, okay, it has been standardized for amplification process. A primer has been extracted from a bacteria, that is high temperature tolerable bacteria, that is high thermostable bacteria, that is known as the Thermotyphus aquaticus bacteria. The gene sequence from the Thermotyphus aquaticus have been extracted and they have been usable as a means your enzyme for this purpose, means your polymerase enzyme. Normally, as we know from our previous knowledge, that polymerase works from 3' to 5' in it and proofreading activity. Okay? So we are applying your polymerase. So polymerase, what exactly it will do? It will be run the primer into forward. Okay? Similarly, the long chain of DNA will be prepared. Okay? So this will be after priming and annealing, there will be renaturation or extension. Okay? Similarly, one base, there are n number of cycles, normally 30 cycles. At the end of the result, 30 cycle, 1 billions of the Gene sequence. My target gene sequence will be there inside the test tube. Means what exactly the story is? Conclusion of the story is we have a single gene sequence. Right now we have billions of gene sequence. Okay? How this happening? This is happening through the amplifications. Okay? So amplification is nothing but a process of enhancing the number of gene sequence inside the laboratory condition. Okay?